Today, before we get too far into Chapter 12, Section 3, we need to talk about something called the unit circle. And our objectives today is we need to know sine and cosine as well as the other four trig functions based on the unit circle. And this is all part of computing by hand without use of calculator the values of some well-known trigonometric functions, which we started in the previous lesson with the 45-45-90 triangle and the 30-60-90 right triangle from geometry. So while we can use those triangles from geometry to find 30-60-90, 45-45, 90, there are some ratios that we need to find using another method. These are the ones we called in the previous lesson the quadrantal angles. Remember, those were the angles whose terminal sides were on the x or y axis and would include 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So to assist us in that process, we use something called a unit circle. A unit circle is a circle whose center is at the origin of the x and y axis, which is 0, 0. And it's called a unit circle because the radius is 1 unit. So let's take a look at that. And what happens there is that that circle intersects the x-axis and it intersects the y-axis at these 4 points: the point 1, 0, the point 0, 1, the point -1, 0, and the point 0, -1. With that information on the positive x-axis, if our initial side is here on the positive x-axis and our terminal side is there, that's an angle of 0 degrees. Again, you can see that this is a unit circle because we're marking off that the radius is 1 unit, whether it's left and right, up and down, again left and right, and down. The radius of that circle all the way around is 1. So with that, again, if the initial side was on the positive x-axis, the terminal side was there also. That's a 0 degree angle. Initial side is starting out on the positive x-axis. Terminal side here on the positive y-axis, that's a 90 degree angle. If our initial side is on the positive x-axis, and our terminal side, after rotating counterclockwise, is on the negative x-axis, that's 180 degrees. If we have an angle starting on the positive x-axis and rotate counterclockwise down to the negative y-axis, that angle is an angle of 270 degrees. And of course, if we go all the way around, we start with the initial side on the positive x-axis, rotate 90, 180, 270, and 90 more. That brings us around to 360, which is a coterminal angle of 0 degrees. Alright, what we want to do now is we want to keep that in mind, and we'll have to scroll back and refer to it in a little bit. But we want to try to find sine, cosine, tangent, cosecant, secant, and cotangent of any of those quadrantal angles. So the reminder, since we don't have triangles here to work with, opposite over hypotenuse, adjacent over hypotenuse, opposite adjacent, etc. aren't going to work for us too well. But we can see that in the unit circle, we have an x value of a point, we have a y value of a point, and we have a radius of 1. So the definitions we need to work with is sine is the y value over the radius, cosine is the x value over the radius, tangent is the y value over the x value, cosecant of theta is the radius over the y value, secant of theta is the radius over the x value, and cotangent of theta is the x value over the y value. And this is the reason we had to learn definitions for both the sides of the triangle opposite over hypotenuse, as well as the y value over the radius. So for our first example, what we want to do is find all 6 trig ratios for a 270 degree quadrantal angle. And remember that I'll scroll back for a second, at 270 degrees, remember we have a radius of 1, and we also at 270 degrees have a point of 0, -1. So since all of this won't fit on the screen at the same time, I wrote it down here as a little reminder. So for that 270 degree angle, the x value is 0, the y value is -1, and the radius of a unit circle is still always 1. There's a little miniature version of that. Hopefully we can still read something that small. So let's take a look at the sine of 270. Sine was defined as the y value over the radius. So for 270, the y value is -1. The radius is +1. And so we'll start with -1 over +1, and then we'll reduce and simplify that as far as possible. -1 over +1 is +1. The cosine of 270, as we'll recall, is the x value over the radius. The x value of this point that's on my 270 quadrantal angle is 0. The radius is still 1. So 0 divided by 1 is going to reduce to give us a 0. Tangent of 270 degrees, that was the y value over the x value. So the y value of my point where the unit circle crosses the x and y axis for a quadrantal angle of 270 degrees. The x value is 0, the y value is -1, and -1 over 0, of course recall the definition of irrational numbers that we cannot have 0 in the denominator. Since the definition says we can't have that, this defies the definition, and we therefore say that this is undefined. So the tangent of 270 degrees is undefined. Now let's start looking at the other three ratios. The cosecant of 270, as we will recall, of course, don't forget cosecant is the reciprocal of sine. So instead of y over the radius, which is sine, the reciprocal would be the radius over y. And the radius for any unit circle is 1. The y value is -1. And 1 divided by -1 is -1. The secant of 270 degrees, don't forget secant is the reciprocal of cosine. So that should be the radius over the x value. The radius is being 1. The x value being 0. Again, that gives us a 0 in the denominator, which is undefined. Let's look at the cotangent of 270. Don't forget cotangent is the reciprocal of tangent. So instead of tangent being y over x, cotangent is x over y. The x value being 0, the y value being -1, and 0 divided by anything is 0. So in addition to knowing the 6 trig ratios, sine, cosine, tangent, cosecant, secant, cotangent, of 30 degrees, 60 degrees, 45 degrees, based on our triangles from geometry, we need to use the unit circle to help us find the 6 trig ratios for the following, and that would be a 0-degree angle, a 90-degree angle, a 180-degree angle, or a 270-degree angle, or a 360-degree angle, or any others that are coterminal with these. So these are things you'll need to be familiar with. The unit circle, just wanted to give a little bit of emphasis on this. I'm only doing 270 degrees. For an exercise, we may have you do 90 degrees, 180, or 0, or 360. So that's the unit circle, which will help us as we do the rest of Chapter 12, Section 3.